Since 1965, the Denar pantograph has provided a means of recording mandibular movement as dictated by the bony anatomy present in the temporomandibular joint. Many practitioners working with the pantograph during these last 18 years have found that the most difficult and time-consuming aspects of the procedure were in mounting the pantograph and setting the articulator. With that in mind, the Denar Corporation has now developed the Pantronic. The purpose of this tape is to demonstrate the Pantronic, illustrating the advances made by Denar using electronic technology. Reference points and planes are measured on both the right and left sides. For demonstration purposes, we are locating the posterior reference point as an average rather than taking an exact hinge axis recording. The anterior reference point is measured from the incisal edge of the maxillary lateral. The horizontal planes are developed by a line which would connect anterior and posterior reference points. Clutches are fabricated just as with the pantograph. However, one must bear in mind that the Pantronic sidearms are heavier than those of the pantograph. Therefore, the clutches must be very retentive and stable. Anterior crossbars are attached to the clutches. The right and left micro-adjustable recording table sidearms are now attached to the maxillary anterior crossbar so that the reference pin locates the posterior reference point or arbitrary hinge axis location. The protractor scales are set to align with the horizontal reference planes on both sides. The sensor stylized sidearms are mounted onto the mandibular anterior crossbar and positioned on the appropriate sides so that the horizontal sensor styli are over or slightly anterior to the hinge axis point, and so that the sagittal sensor styli are lined up within circles marked on the posterior reference tables. The O-rings, one for each stylus, should be retracted to allow the styli complete freedom of movement. Rubber bands should also be attached to allow the styli to maintain constant contact with the tables. An air supply may also be attached to confirm centric relation position. We are now ready to activate the computer. When the computer is activated and reset is pressed, it automatically prints out name, number, date, and RRP. RRP is the abbreviation for right reference plane. The angle is read from the protractor and programmed into the computer. The computer next prints LRP, or left reference plane. This is also programmed into the computer. The computer now is able to arrive at horizontal, sagittal, and coronal planes passing through each condyle. The clutch angle protractor is used to relate the angle of the clutches with the mid-sagittal plane. Clutch measurement under 5 mm may be programmed into the computer. A red light now appears indicating that the computer is ready to begin recording the mandibular movements. A bimanual manipulation technique is used to seat the condyle in its most anterior superior position in the fossa for centric relation. All excursive movements will originate from this position. 3 recordings of each movement are made. The first movement is right lateral. Once the mandible is in centric position, a foot pedal attached to the computer is pressed and will be held down through the excursive movement. When the pedal is first pressed, the computer emits a soft beep indicating that it is ready to record the movement. At the end of that movement, a louder confirming beep is emitted. This indicates that the movement has been recorded. Recordings are taken 3 times to the right, 3 times to the left, and 3 times to protrusive. On lateral movements, pressure may be applied medially on the angle of the mandible on the orbiting side. This will induce recording of an immediate side shift. If an error occurs, a double beep is heard. The information immediately preceding that beep can be erased by quickly pressing and releasing the foot pedal. The practitioner may choose to erase and reprogram any preceding movement if so desired. Once the third protrusive movement is recorded, the computer begins to automatically print out the data. The first set of data is numeric. These values correspond to the adjustments made on the D5A fully adjustable articulator. The numeric information delivered is an average of the 3 similar excursive movements. In addition to these values, the Pantronic can also determine the medial and superior wall inserts necessary to simulate these condylar movements. If so desired, the computer will also print out graphically a series of plots simulating pantograph tracings. They are enlarged, highly detailed, and represent 1 or all 3 sets of excursive movements. These may then be visually compared for consistency. Using the numerical information provided, one may set the articulator quite easily and simply. We in dentistry are fortunate. The technology is constantly being upgraded in order to facilitate more successful endeavors. The Denar Corporation has provided us with the means to help our patients more than ever before, while at the same time making our task that much simpler.